to my C# programming in window form of a numerical method calculator. Here are my codes in my numerical method: the graphical, incremental, bisection method, postposition method, second method, and Newton-Raphson method. So this is my code for the display when I enter calculate of in each method. Bisection, false, second Newton, and in another class, this is where I place the function of the arithmetic operation, the plus minus multiply and divide, the sin, cos, and tan, and also the point, exponent, and parenthesis. Now, here in my design of the calculator is where we select our method, the upper limit, lower limit, tolerance, saturation limit, the equation, and this is where it displays the graph and its legend, and this one is the iteration table. So let's start with the graph method. Here's my graph method, guys. This is where this is the iteration table display and the calculation here. Double that like max value, the lower, and the evaluator, and more. This is where we locate the graph legend, and next is my incremental method function. This is the graph table and the iteration table, the variables, I mean the variables and the formula. Next up is my bisection method. This is where the define the range. Next is the oh, oh my bad. This is my display for the graph in my bisection method. Now here's the calculation. Here's the formula and the table for the bisection method. Next up is my false position method, where this is the iteration table together with its formula and the next up is my second method, the formula, then my code. Next to second, lastly, is my Newton-Raphson. Here I place the formula, and now we will go to the window form to see how it works. It will take a while because the Sharp consumes a lot of RAM. Okay, here is my numerical method calculator. This is where we choose graph method, incremental, bisection, post position, second method, and Newton Raphson. Let's start with the graph method. Graph will ask the maximum and the maximum limit and the start of the start of the graph. So let's we will end at 3 and start with 1 point. Oh, clear. 0 point 0.001. Iteration limit is 6, and the equation is e raised to the power of negative x. Oh, negative x. My It's lagging. Okay, go back. Uh, Minus x, calculate. The approximate root of it is 1, and here is the graph, and here is the iteration table of the graph method. Next up, we'll move on to the incremental method. Let's say the upper limit of this is 5, and the lower limit is 0. Limit iteration is, let's say, 11. We will still use the same equation, e raised to the power of minus x minus x calculate if a y. Okay, here. So, as you can see, the equation we show there is no root found in 11 iteration. So let's move on to the bisection method. So let's say we'll still use the same equation, but let's move the iteration limit up to 20. And here we have found the approximate root of the equation of bisection method, which is 0.5673 right here. Next up, and this is the graph, it shows multiple root. So let's move on. Say the upper limit is 1, so it's 0.5, tolerance is 0. Just 3, use the equation, use another equation, which is 3 times x plus sin x plus e. Calculate. As you can see, we have found the root, which is negative 0.69. Right here is the depth of iteration of post position. Now let's move on to the secant method. Secant method, we have changed the initial guess and the initial guess of x0 and the initial guess of x1. So let's say the initial guess right here is, let's say we go with 1. Go with 20. So it's been covered up because of the color, and the 0 is, let's say, 5. You still use the same equation, and here is the spend method. Here we found the root, still the same root, and for the Newton option, the initial guess one is disabled because we only need one initial guess for the Newton option. So let's say the initial guess over here is 6, and the iteration limit is 5. Calculate, and here is the sugar of the Newton option. That's all for today. I am Luke Earthmarks Juliano Aton, and thank you for watching.